Okay, Intermediate Algebra, Chapter 2.3. We're going to talk about solving. I know you've learned solving quite a bit before, so we won't spend too much time on it. We're going to briefly review solving and checking, discuss how to structure your homework, and work on killing some fractions. Something that you might not have ever thought of before. We use the order of operations, PEMDAS, whenever we're evaluating or simplifying, like when you have 2 times 3 plus 4 squared minus 5. You do parentheses, then exponent, then multiply, then subtract. Order of operations, PEMDAS. If you've already done your simplifying, then you do that backwards when you're solving. You use SADMAP. If your expressions and equation are simplified, you'll probably deal with the addition, subtraction first, then the division, multiplication, then exponents and parentheses. So I'm going to solve and check this. Now, before I do the solving, I actually want to simplify. For the record, I could just solve, right? Like, I could actually subtract the 3 first, and that would be me doing subtraction addition first, and that gets me negative 2 times x plus 4 equals negative 14. Then I could divide everything by negative 2 and do the multiplication division next, and that gives me x plus 4 equals negative 2. Then subtract 4 one more time, because now I'm dealing with the stuff inside the parenthesis, and that gets me x equals negative 6. So you actually can solve it that way. As long as you're doing the same thing to both sides of an equation, as long as you divide both sides by the same thing, multiply both sides by the same thing, whatever, you can really do whatever you want. So what we do is we show you the most efficient way, the methods that will always work every time. And that means the first thing you should do, if ever possible, is simplify. So I could simplify this by distributing the negative 2. And these two expressions are equal to each other. Then I combine my like terms, so I get negative 2x minus 11 equals negative 11. Sorry, that's not true. Negative 2x minus 5 equals negative 11. At this point, I've done all my simplifying. The simplifying is done. Now I'm going to start solving. So when I start the solving, I'm going to deal with the addition or subtraction first. I add a 5 to both sides, and that gives me negative 2x equals negative 6. Notice how I'm not saying these things are equal to each other anymore. I didn't put an equal sign over here because I've actually changed the value. Negative 2x minus 5 is not the same as negative 2x, so I don't put an equal sign. Divide everything by negative 2, and I get that x equals 3. I have solved. I'm now going to check. When you check, put a little question mark here. We're saying, is 3 minus 2 times 3 plus 4 equal to negative 11? Like, is it? I don't know. We're not sure. We're checking. I don't want to say something is equal if it turns out they're not equal. But since x equals 3, I plugged a 3 in for this x. I should probably write down that initial equation first. I'll have you do that also. So I'm going to write this first. 3 minus 2 times parentheses x plus 4. I know that does equal negative 11, so I don't put a question mark above that. And now this I'm just evaluating, so I can do 3 plus 4 first. Yes, they equal each other. Boom. We solved. We checked. Way to go. We're the best. So simplify, solve, check. It's pretty straightforward. So I want to talk now about how to set up your homework, how your work should look in your homework. You're going to be assigned problems from your book or from a worksheet, and the problems are going to be in a big list over here. If you're doing this on iPad, go ahead and screenshot that list and put it in your document. But then off to the side, whichever problem you're doing, write its number and rewrite the equation in your handwriting before you start solving. Okay? So don't try to do the work in right here. Just off to the side, rewrite the equation, and then show the work. So next I'm going to distribute 3x plus 3 minus 6x minus 12 equals negative 6x. I'm going to simplify and combine the like terms on the left side. So 3x minus 6x is negative 3x, and 3 minus 12 is negative 9. Now I'm done simplifying. I want to get my x's together on the same side. Since there's only one term on the right, I'm going to move this over. It doesn't really matter what you move, but oftentimes students get confused when there's no term there. Here's what I mean. Suppose I'd been at this point right here, and I thought, okay, I want to move the negative 6x, so I add 6x to both sides. You can do that. That's no problem, as long as you do the same thing to both sides of the equation. Do whatever you want. but this ends up with 3x minus 9 equals, and it's like, duh, what happens over here? Well, the answer is pretty simple. It's just 0, and that's fine. You're allowed to have 0. You just keep solving. But sometimes having a 0 over there confuses students. X equals 3. So now I'm going to check. Is 3 times 3 plus 1 minus 6 times 3 plus 2 equal to negative 6 times 3? I'm going to put a big question mark here, and I'm going to label the fact that I'm doing the check. This is me checking. So here's my solution. Here's me checking the solution. Well, 3 times 4 minus 6 times 5. Is that the same as negative 18? Well, 12 minus 30 does equal negative 18 because negative 18 equals negative 18. So boom. Notice, once I was sure they were equal to each other, I put equals. I didn't ask anymore. I said, yes, 12 minus 30 is negative 18. So there, I've solved it. Okay, there's number 1. Now I'm going to do number 2. And ideally on your homework, I'd like everything to be in big rows or columns, really big columns taking up your page. Because of how I'm presenting, that's going to be tough for me to do because I want to leave all this stuff right here on the screen for as long as possible. So I'm going to kind of jump around on my page, but I would like your page to be really clear and organized with your problems. Here's me doing number 2. This one, I just want us to make sure we can handle fractions. What's a good color I've not done in a while? Here we go. I'm going to subtract 4 from both sides, which gives me 2/3 x equals 11. Remember, I never divide by a fraction. I multiply by reciprocals. So x equals 33 over 2, because that was 11 over 1. Now that is my solution. You might think, oh, I don't want to check that. How do I check 33 over 2? Well, it turns out usually with fractions, the checking isn't that bad. Because I'm going to take 2/3 x plus 4, which equals 15. I go back to the initial equation, which was here. But when I plug in 33 over 2, and sometimes doing that with a parenthesis, and sometimes changing colors can be really nice. When I plug in 33 over 2 and I'm asking if these are equal to each other, these 2's cancel out immediately. And that'll happen really frequently. The fraction just cancels immediately. 33 divided by 3 is just 11. And yes, 11 plus 4 does equal 15. So my check is good. You're going to be solving and checking in your homework. Here's the last one. I have number 3, which is 3/4 of x minus 1 over 5 equals 1/2 of x. A couple things I want to make clear before I start solving this, just so you know. There's no negative, well, there are some negative fractions here. This is the same as this, which is the same as this. Those 3 fractions all mean the same thing. The negative can be on top, in front, or in the bottom. We never put it on the bottom because denominators should be positive, but it can be. We just don't like it there. We would never do this because those just cancel each other to become positive. So don't have 2 negatives in a fraction. Also for the record, this is the same as this. The x can be on top or coming off to the side, 3/4 x, either one. Okay, I want to solve this, and it has a whole bunch of fractions. And I know that we're not totally high on fractions. So when we have an equation, this only works when you have an equal sign, an equation. But when we have an equation, we have the option to kill the fractions. You kill the fractions by using the lowest common denominator. In this case, the lowest common denominator is 20. 20 is the first number that 4 and 5 and 2 go into. The secret is it doesn't have to be the lowest common denominator. It could be any common denominator. I could even use the number 60 if I wanted to. We just use the lowest one because it makes the numbers simplest and involves the fewest steps. Okay, the lowest common number is 20. So I'm going to make each of these fractions have a denominator of 20. The way that I do that is I multiply the first fraction by 5 over 5. The second fraction by 4 over 4. And the third fraction by 10 over 10. This now gets me 15x over 20 minus 4 over 20 equals 10x over 20. Once everything has a common denominator, I can multiply both sides by 20, and all these fractions cancel. And I just get 15x minus 4 equals 10x, and it's beautiful. We've killed the fractions. We've just murdered these fractions right in their face. So you get a common denominator, you can kill the denominators by multiplying both sides by whatever that denominator is. In this case, it was 20. Now I'm just going to solve. Again, since I only have just one term on the right side, I'm going to move the 15x on the left side. You don't have to do it this way, but you can. It doesn't matter. That means that negative 4 equals negative 5x. Divide both sides by negative 5. And we get that 4/5 equals x. There is our solution. Something I want you to understand. Here, we're multiplying by 1 every single time. The fraction 5 over 5, 4 over 4, and 10 over 10. Those are all just the fraction 1. And when you multiply something by 1, it doesn't change the something. So I really should say that this right here is equal to this, because I've not changed its value at all. When I multiply everything by 20, then the value changes, but multiplying by 1 doesn't change anything. So you're free to multiply anything by 1 whenever you want, or to multiply both sides by the same thing whenever you have an equation. Those are two of the main things we do in an algebra class, actually. Multiply by 1, do the same thing to both sides of an equation. The other main thing is substitute, which I would do when I checked, but I'm not going to check right now because I want to wrap up this video. So, there we go. Thanks for watching. Remember, you use PEMDAS when you are evaluating or simplifying. Use SADMAP when you're solving. Make sure you check, make sure you write clearly, make sure you have a good day. Hey, thanks for watching. Cosine wave. Here it goes. Bang. Back and forth. Back and forth. Like, subscribe, share, tweet. I don't know. Do you guys still tweet? Is tweeting still a thing? I made this in 2017, and by now, for all I know, it's like 2035, and you're still watching my math videos, because math doesn't change that much. What are you doing now? Are you like connected to the hive mind? You've probably got like antennas implanted behind your ear that connects you to the hive mind that tells you what to do at all times. Resist, fight. Just because iPhone sells it to you doesn't mean you need it. I don't know what I'm talking about.